Welcome back to Basic Mathematics. In this video, we're going to be starting to develop a basic number sense, which is fundamental to all of the discussion we'll be having for the rest of the course. Before we get into that, I invite you to take a minute with me to get yourself into the right frame of mind to start working on an online course or starting into coursework at all. Sit down in a comfortable chair at a table or desk. Make sure that you have a notepad or whatever else you're working in spread out in front of you. Take a minute, close your eyes, and just relax. Take a deep breath. Breathe in. Breathe out. For many of you, mathematics is a scary idea. For many of you, you are nervous about studying this mathematics course. I've heard many times over the years that I've taught this course, students come to me on day one. I've always been bad at math. I have no hope of passing this class. My greatest delight as an instructor is the great number of them who come to me at the end of the course and are able to say, "Thank you. I finally feel like I understand this." If you come into this course with the idea that it's going to be a struggle, and if you come into this course with the idea that you're not going to get it, you have already lost. Treat all of your courses with an open mind. In this course, we're going to start at the very beginning. For some of you, you're going to wonder why we are starting so early. For some of you, this first week is going to be the most challenging content you see the entire semester. My general philosophy in teaching this course and teaching basic mathematics is that everyone taking this course already knows about half of the material in the course. For some of you, it's going to be the first half of the course. For some of you, the first half is going to be the hard part, and the second half is the stuff that you already know. For others, there will be a sprinkling of topics throughout, where some of these things you remember, some of these things you kind of remember having seen at some point in the past, and others you really don't remember having seen ever at all. And that's okay. We'll get through it. We'll take things one step at a time, and we'll make sure that this all makes sense. Take one more deep breath. Breathe in. Breathe out. We've got this. Let me get my head out of the way, and let's get started. When we talk about numbers, first of all, understanding even what that means is an incredibly difficult concept. A number is an abstract idea. Just that much is half of the problem. You will never find a number in the world. They don't exist. But by working with them, we can answer questions. A number is an abstract idea abstract idea which helps answer questions of how many or how much. There is a YouTuber named Vi Hart who calls herself the recreational mathemusician. I love her definition. Numbers are imaginary friends which help you do stuff. In studying numbers, we tend to break them down into pieces and try to build through each piece on its own. The natural numbers, which are sometimes called the counting numbers, are the real starting point of our discussion. As the alternate name suggests, the natural numbers are the numbers you use when you are counting. 1, 2, 3, 4, and so on. And the natural numbers are great for a number of things, but they aren't really enough. So, one of the most important advancements in the history of mathematics, which is really the key idea of Arabic scholarly pursuits, the whole number. For hundreds, thousands of years, scholars in Europe could not figure out that 0 was a number. Eventually, concepts from the Arabic world were imported into European thinking, and we introduced 0 as a number in itself. So if we start counting at 0 instead of at 1, we call these things the whole numbers. And for this week and next week, the whole numbers are going to be the tool that we are working with. Once we're done with the whole numbers, we're going to move onward to a new group of numbers, which are called the integers, sometimes referred to as the signed numbers. That really does not look like it says signed. Let me try that again. My eraser isn't working correctly today. I'll troubleshoot that later. The signed numbers are the positive and negative numbers combined all together. So we still have 0, we still have 1, we also have -1, we have 2, we have -2, and so on. And then one more set of numbers that we will be looking at in this course is the rational numbers, which you're probably more familiar with calling the fractions. There is a slight difference between the rational numbers and the fractions. I'm not going to worry about the distinction, but technically speaking, when we say rational number, we mean positive or negative. When we say fraction, we mean just the positive ones. But things like 1/2, 1/3, 3/5, and so on. There are other numbers beyond this group. You may have run across the name before of the real numbers. We'll talk a little bit about the real numbers a little bit later on this semester. The real numbers allow us to introduce some interesting concepts that don't have simple fractional representations. There are numbers even beyond that. If you go a little bit further in algebra, you'll introduce yourself to the complex numbers or the imaginary numbers, which have some very strange properties involving polynomials, but that's well beyond the scope of what we're going to be looking at this semester. Like I said, for right now, we are going to focus our discussion on the whole numbers, and the other numbers are going to come into play a little bit later on. In fact, this week is a skill drill week. The assignments that you have to look at this week are going to ask you to perform some basic operations on whole numbers. As I said in the introduction, some of you are going to find that this is the single easiest thing you've done all semester. Others of you are going to find that you are finally getting a chance to do something that you've known that you needed to do for quite some time. But we have 4 basic operations when it comes to working with numbers: addition, subtraction, multiplication, and division. I know that you are all familiar with addition, subtraction, multiplication, and division on whole numbers. But for some of you, you have relied on a calculator as a crutch for so long that you don't really remember how they're supposed to work. So for this lesson, I want you to take the time and really drill those skills. You should know offhand that 3 plus 5 is 8. You should know offhand that 27 minus 9 is 18. You should know offhand that 7 times 8 is 56, and you should know offhand that 72 divided by 6 is 12. I suggest looking at the addition and multiplication tables first. The addition one, I don't think anyone is going to have any real issue with. Multiplication is where things really start to get tricky for some people, again, just because it's a skill that needs to be practiced. But if you take the numbers from 1 to 12, and you multiply by the numbers from 1 to 12, you should be able to fill in this entire table on your own. 1 times any number is that thing. 2 times any number, counting by twos. 2, 4, 6, 8. I always like getting to the 10 row because trying to fill this out multiplying by 10 is one of the easier ones. The 11 row is one of the more fun ones. And then when you get to the 12 row especially, because multiplication has what we call the commutative property, 12 times 7 is the same thing as 7 times 12, which we already wrote down. So taking advantage of that symmetry, if you look at this table and you look at, let's try that again, see if I can be a little bit more careful in how I draw it. Look right down the diagonal here where I'm multiplying a number by itself. And if you envision, if I had written this out in a perfect square and folded along that diagonal, things would match up. Right? 8 times 2 is 16. 2 times 8 is also 16. 12 times 6 is 72. 6 times 12 is also 72. It doesn't matter what order you write the multiplication in, you get the same answer, which means that there's really half as much to memorize as it looks like at first glance. The multiplication skill drill exercises will give you a chance to play around with this quite a bit. And then once you have addition and subtraction taken care of, addition and multiplication taken care of, subtraction and division are the inverse operations. If you write out an addition problem and you take those numbers and you write them in the reverse order, you can change from addition to subtraction. Likewise, if you take a multiplication problem and you write those numbers in the reverse order, then you have a division. 7 times 12 is 84. 84 divided by 12 is 7. And that's really why it is so important. Right? Calculators are really good at these sorts of operations. And a lot of people try to lie to themselves and say, well, my calculator can handle this. Why do I need to be able to do it in my head if I can just use a calculator? And the reason is that honestly, I don't care about the multiplication. If that was all it was, I would not care whether you were able to look at 7 times 12 and off the top of your head come up with, oh, that's 84. But I need you to be able to look in the other direction. I need you to be able to look at 84 and say, oh, that's 7 times 12. I need you to be able to look at 48 and say, oh, that's 6 times 8, and so on. So take the time, work through these 4 skill drill exercises on addition, subtraction, multiplication, and division. And then in the next video, we'll look at some other properties we can use to build from here. Right. Thank you for joining me, and I'll see you in the next video.